Hi, hello. Welcome to my next lecture on metallurgy. In the previous session, I have discussed about the different introduction parts of metallurgy and the important ores of different metals explained and what are the steps involved in the metallurgical operations types only I have explained. In that first one, we will start with the first one, that is concentration of ores in this class. Concentration of ore. Concentration of ore. We are all familiar that whatever the removal of unwanted materials are there in the ore, called sand, clay, etc., is called as concentration of ore. So when you remove the unwanted materials from the ore, that removal process we will call it as concentration of ore. You can also call that is dressing or benefaction. Is also called as concentration, or we can call that is the dressing of ore, or you can call that is the benefaction. Benefaction of the ore. It involves several steps actually. For the selection of these steps depends upon the differences in the physical properties of the compound actually. We have to understand the physical properties of the compounds, the metal present in that of the that of gang. That means, how can we understand this point is several steps are there in the concentration of ore. In the several steps, and a selection of these steps depending on the differences in the physical properties of the compound of metal present and that of gang present. So we have discussed about one important terminology in this metallurgical operation, that is gang particles. That means gang particles are also known as unwanted materials called sands, clay, etc. are called gang particles. Even there may be metals which are not required for our extraction of metal. So one metal you want to extract means if other metal is maybe present as a impurity, in such a case that is also called as unwanted material. But most cases the unwanted material is nothing but sand, clay, etc. Right? Now, the type of the metal available, facilities and environment factors are also taken into the consideration. So when you are doing the concentration of ore, what type of metal you are extracting or doing concentration, and all these things are important, and environmental factors also will be considered in the concentration of ores. Some of the important procedures of concentration of ores we'll see, and that the first one I'd like to introduce, that is hydraulic washing. Hydraulic washing. So here, when I am talking about hydraulic washing, actually it is based on the differences in the gravities of ore and the gang particles. That means the main principle in the hydraulic washing is we have two things are there. Ore is there and another one is nothing but gang particles are there. They should have different gravities. They are different, or you can say they are different in gravities. Okay. or gravitational force. So when a differences are coming between the ore and gangue particles, then in the name itself we are talking about hydraulic washing, right? In the name itself, this phenomena is making one thing, that is wetting tendencies. That means we will wash the ore along with the gangue particles. Therefore what will happen, depending on the gravity, ore and gangue particles will be separated out. That's why we will call this is gravity separation. It is also a type of gravity separation. We can say gravity separation method. Gravity separation. That means hydraulic washing is a method also known as gravity separation method, because we are checking about the differences in the gravities of ore and gangue particles in this washing process. And in one such process, what happens in this process, we have an upward stream of running water is used to wash powdered ore. So we have a powdered ore is there. Powdered ore is there. And what we will do is nothing but we will wash this powdered ore with water. So that is actually upward stream. Upward stream. So here we have powdered ore is there, assume, and this powdered ore is said to be washed with water, in which water is coming from the bottom and ore is present, powdered ore is present at the top. What will happen? The ore will get completely washed with the water. In such a case, the heavier ore particles or heavier particle, which may be gangue particle or the ore particle, they will retain in the plate, and the remaining rest of the lighter particles will wash away with the water. That means two things we have to remember in this one. We used to call the apparatus is willfully stable. That apparatus we will call it as willfully table. It's nothing but an inclined table. From that top, this ore will be falling, and from the bottom water will wash the ore, and in the inclined position what will happen, the lighter particles will come down to the table and heavy particles remains on the table. That is a table which contains some baffles. That means there are some pores are present in the table. That is the name of the apparatus. And the lighter gangue particles, if they are present really, then they will get washed away and heavier ore particles left behind on the table. So here we can say lighter gangue particles washed away with the force of stream, washed away, and heavier particles. What are heavier particles? The heavier ore particles, we can say, the heavier ore particles will get left behind over the table. So this is the meaning of hydraulic washing. The step of the concentration of ore, if we identify the gangue particles or lighter particles than ore, then we can easily use this method called as gravity separation by washing the ore using an upward stream of water over a Wilflish type of table. It's an inclined table, and in that table powdered ore with gangue particles is present. Once this water stream started falling onto the powder, then the lighter gangue particles will separate it out, and heavier ore left behind on the table, that will be separated out. So this is one an interesting idea of the concentration of ore called hydraulic washing. We will see the another method that we will call it as magnetic separation. Magnetic separation. Most of you know, in the name of this method itself, we are saying magnetic separation indicates that magnetic properties of the components like ore and gangue particles, if they are different, we can able to separate this gangue and ore particles by knowing the differences in the magnetic properties of the components. Either ore or gangue particles, any one of these is said to be capable of being attracted by magnetic field. Then such a kind of separation we will call it as magnetic separation. Such separations will usually carried out in a case of iron ores. So usually carried out for iron ores. Usually we will employ this magnetic separation usually for iron ores. This magnetic separation will be employed. In this, what will happen? There will be a magnetic roller will be present, magnetic rollers, and this around that there is a belt, what we will call it as the magnetic roller. Over that a belt is also present, and over this this ore particles, we will take ore with powder, that means grounded ore in powdered state or ground state, powder state will take, and it will automatically get fall over the belt, and it will go along with the wheels, and there are two kinds of heaps will be developed. The another one, there are two things will be coming onto this one here. So two things, there are two containers are there here. The one container is kept for substances having a greater magnetic tendency. The other one will call it as non-magnetic particles. So magnetic particles, non-magnetic particles. Here we will say these are magnetic particles. And this belt actually continuously roll, and this we will call it as a magnetic roller. A magnetic roller, and here the fall of these particles takes place depending on the tendency of magnetic properties. Okay, so this is the schematic diagram. In this this we can call it as, this diagram we will call it as magnetic separation picture. Magnetic separation method. So we have any kind of material fallen away from the magnetic roller, the materials are said to be non-magnetic. Non-magnetic properties, particles. Now, what is the main principle of this magnetic separation? This is based on differences in magnetic properties. Differences in magnetic properties of components. What are the components? You know, ore and gangue particles. Components may be, one is ore, another one is gangue particles. Usually ore is having a magnetic property in the case of iron that will fall closer to the magnetic roller, and gangue particles will fall away from the roller. So that's why here we are assuming gangue particles are non-magnetic particles. It may be different, but in a particular case, we are saying magnetic and non-magnetic particles in this discussion. If you observe the magnetic, non-magnetic cases, in the electromagnetic separation, we can also call this an electromagnetic role separation. In this method, actually, we will use chromite ore for its concentration, FeCrO4. That ore, we will call it as chromite ore. The separation used for chromite ore, or else we can use this one. We will use our chromite ore as containing non-magnetic siliceous gangue particles. In this, we have non-magnetic siliceous gangue particles are present. This is containing non-magnetic siliceous gangue particles. Gangue. That is one example I can say. The another important thing here is we will also use this method for wolframite, that is FeWO4. Wolframite, this is called as wolframite, and in this one cassiterite is the non-magnetic impurities present. Cassiterite, nothing but tin stone, is a non-magnetic impurities present. So that is gangue particles. On the same manner, we have another important iron ore is there, that all we know, that is magnetite, that is Fe3O4, magnetite, hematite, Fe2O3, and limonite, that is PeO2, can be separated by this method. In these methods, we have titanium dioxide is the impurity which is present. So, dear students, you observed magnetic separation or electromagnetic separation method is said to be employed for the materials, that means ores that contain non-magnetic impurities. Usually this magnetic roller, because of its magnetic behavior, it allows the particles containing magnetic behavior to fall closer to it in this electromagnetic separation. Let us see the next one. The next method we will call it as froth flotation. Froth flotation method. Froth flotation method. As of now, we observed hydraulic washing and magnetic separation methods. In both these methods, we came to know that there are some metals are selected, ores are selected for concentration of that particular species. But in the froth flotation method, you can ask what kind of the ores are especially said to be subject to concentration. That time, the only one answer we have, that is nothing but sulfide ores. This froth flotation particularly designed for sulfide ores. Sulfide ores. Earlier we told the electromagnetic separation or magnetic separation, which is especially used for the iron ores. And in this froth flotation method, we will give that particular information, that is, this is for sulfide ores especially, we will use that method. So this method is used particularly for sulfide ores. In this method, we will have an idea. That idea is nothing but suspension of powdered ore is made with water. That means earlier we told in the hydraulic washing, we used to wash the ore with a upward stream of water. That time also the ore and gangue particles came in contact with water. But here they are in contact with water, but we are not taking the running stream of water. Here we are taking the complete mixture of water. So we are taking the ore, powdered ore, and adding water to it. In that, there are some particular materials will be added in that one. That materials will make the separation of ore from the impurities. That we will see in the diagrammatical approach. So in this, we have a picture is there. That picture I will bring it to your notice. So we are taking, I will write the one diagram for this discussion. Like this one container is there, and in this container there is a suspension of ore with gangue particles is there, and to just create some what we call some agitation, mixing of this entire solution will be done by using one apparatus that we'll call it as rotating paddle. This is one apparatus is there. Using this apparatus, we will mix the entire liquid. That is apparatus, we'll call it as rotating paddle. So simply it is a stirring of the mixture. The same time, and this is having some extension is there. That also I'll show it to you. In this, here, pulp of ore plus oil will be taken. Pulp of ore plus oil will be taken, and whatever this bottom side of the diagram is there, paddle draws in air and stirs the pulp. draws in air and stirring the pulp. Stirs the pulp. So this is one idea here showing in this diagram. Got it? So we have some bubbles are generated over this one, that is called as froth. So once the froth is developed on the top of the surface of the liquid, what will happens inside this froth, there might be some lighter particles get concentrated because of this bubbling of this liquid via this rotating pedal. So here in this picture, what you understand is nothing but the suspension of powdered ore is made with water. That means powdered ore we have taken, and along with that we have taken water. So both we have mixed. That is called, we are calling as suspension. And after that, what we did is to that we have added some collectors and froth stabilizers. Added collectors, added some froth stabilizers. In the case of collectors, the collectors we will call it as pine oil, that may be pine oil, or fatty acids, or xanthates, sodium or potassium xanthates, etc. Froth stabilizers. What are froth stabilizers? Nothing but these are cresol, anisole, and their derivatives. Cresol, they may be cresols. Aniline, organic substances. They will stabilize the froth, and collectors enhance the non-wettability of the particles. So two things are there here: non-wettability of the particles, of the mineral particles, and stabilizers are said to be added to stabilize the froth. So two things are there. When you add the collectors, what will happen means this mineral particles are there. Na? The mineral particles which are not said to be going along with the water. And another one, froth stabilizers. Actually, these are organic materials you are observing here. They will stabilize the froth. So two things will take place, and the mineral particles definitely get wetted by oils only in this case, because pine oil is there. The pine oil will get wetted by mineral only. Mineral will get wetted by pine oil, but mineral is not get wetted by water. So collector is separating the wetting tendencies of this mineral and the waste particles, what we will call gang particles. Okay. And what about the role play of froth stabilizers is nothing but this froth stabilizers are said to get stabilize this froth. So in the name itself, it is very clearly it is there. That means mineral particles become wet by oils while gang particles wet by water. So what is the wetting tendency? Wetting tendency, how it will be there? That means oil is there that go with the mineral. So mineral go with oil, and water is there. With the water, the gang particles will go. That means wetting tendency of gang particles is with water. Wetting tendency of mineral particles is with oil is there. So this is very clear. This is called as difference between the wetting tendencies of mineral and gang particles. So what is the main principle of froth rotation is nothing but this is also said to be the differential wetting tendencies of the particles. So you can also call the principle is nothing but differential wetting tendencies. Differential wetting tendencies of particles is the principle involved in the froth flotation. As we all know, once we start agitating this mixer, that mixer means a suspension, what happens? The air drawn by the rotating pedal will definitely create froth, and which carries mineral particles, because over in the froth, mineral particle will be there as it is lighter mineral particle. That means gang particle is heavier, that will get settled after the some time. So the froth of light is skimmed off and then dried recovery ore particles. So this is what the actual idea behind the froth flotation. So we can separate the mineral particles and we can separate the gang particles. So we can concentrate the mineral ore, that is particularly sulfide ores. In particular, we have another idea is also there in the discussion. That is nothing but the point to be discussed here is the depressants. Then another important terminology here discussed in the froth flotation, that is nothing but they are also called as depressants. What is the important term involved here is they are used to prevent certain type of particles from coming the froth with air bubbled. So that means depressants are another important materials which are employed in this froth flotation, especially when they are used to prevent certain type of particles, certain type of particles from forming froth with air bubbled. We have a best example for this one is sodium cyanide is there and can be used as a depressant. Best example for the separation of zinc sulfide from lead sulfide ores. So you can see zinc sulfide with 4 moles of sodium cyanide. If you take the equation, the sodium zincate complex will be formed Na2 Zn Cn 4 times plus Na2S. That means what is the important of the reaction is nothing but this zinc sulfide ore will be getting separated from the lead sulfide ore. That means when you are purifying the galena is nothing but lead sulfide is the galena. In that zinc sulfide is present, then what will happens? That zinc sulfide can be separated out using the depressants. So where this ZNS is there, ZNS is there in PBS. That is nothing but galena. In PBS, if ZNS is there, that ZNS definitely will be removed in the form of a complex by sodium cyanide. That important role of sodium cyanide in this froth flotation method of galena is depressant. Okay. So this is our point. That's what given as sometimes we are saying it is possible to separate the 2 sulfide ores. Here there are 2 sulfide ores are there, zinc sulfide and lead sulfide, both are ores. Adjusting the proportion of oil to water using depressants. What are depressants? In this case of ore containing zinc sulfide and PBS, depressant used is sodium cyanide we told, and it selectively prevents the zinc sulfide from coming to the froth but allows the PBS come with the froth. So definitely zinc sulfide is heavier than lead sulfide zinc sulfide is forming complex with sodium cyanide, not lead sulfide. So in that way, the two sulfide ores can also be separated using this method of depressants and this froth flotation. So we can do wonders if scientific treatment, temperament on the attentive to the observations, and the initiative, that innovative washerwoman example, if you see in the books they given, the washerwoman had an innovative mind too. While washing minus overalls, she noticed that sand and similar dirt fell to the bottom of the wash tub. Right. So we was what was peculiar in this is nothing but the copper bearing compounds that had come to the cloths from mines were caught in the soap subs, and so they come to the top, they're telling. So in this entire paragraph given in the textbook, if you read, you will understand that in every work there is a scientific temperament is there, the scientific touch is there, that they are explained. If you can go through this one, in this the washerwoman told her experience to a scientist. Later the idea actually used to separate the copper compounds from rocky and earthy materials in large scale from the cloths, and this way invention was born. At that time only these ores were used in extraction of copper actually, and which contain large amounts of the metal. Invention of froth flotation method made copper mining profitable even from the low grade copper ores. So froth flotation method is employed at that time in the extraction of coppers. So world production of copper soared and the metal became cheaper after using this froth flotation method. Okay. Anyway, this paragraph, if you observe, you will get an idea about how can we concentrate the sulfide ores. Okay. That is one point in the discussion. So in the next session, we will discuss about other important points called leaching of ores. Okay. The next session we will see NCERT 6.2.4 leaching of ores, and after that it will be continued with the extraction of metal from the concentrated ore. Okay. So I hope you understand this session. In this session, I went very slowly by telling about the things related to this concentration of ores in metallurgy. Concentration of ore I have discussed. Hydraulic washing the method of that magnetic separation I have discussed. And what are the important ores under magnetic separation will be considered, that we discussed. Then after I have introduced the most important board examination question, froth flotation. And also in this froth flotation method, usually there are common standard questions and important questions are nothing but what are collectors examples, what are the froth stabilizer examples, what is the depressant, what is the role play of depressant, and the depressant, how separates the two sulfide ores in a given concentration methods of the ores. So this is what we discussed in this lecture. Hope you understand this lecture, and we'll go slowly with this metallurgy, as this is most important theoretical aspect of this second year syllabus, class 12 syllabus, used for the public examination as well as the competitive examinations from this chapter. Okay. Thank you very much. Have a nice day.